I think I first heard about you, it might have been earlier, but the ultimate proof of creation is definitely the thing that sticks out the most. Would you get into presuppositional apologetics, Van Tillian, Bonson-esque, actually getting into things that you can't get around from a philosophical viewpoint, and you either have to go insane or offer another alternative ultimate proof. But then you get to talk about why you can't be arbitrary and all that kind of thing. So I've never really heard you talk about your religious background. Were you raised in a Christian home? What was that like growing up?
Yeah, I was raised in a Christian home. My parents are believers. They're still living and they're good people, and I appreciate that. I have kind of a boring testimony, but I'm very grateful for that. I was saved when I was very young. I was maybe 6 or 7 years old, and my theology wasn't as good then as it is now. But I knew enough to know that I was a wicked sinner, and when my parents took me to church. They read the Bible to me. They got me like a children's Bible, which I still remember that. And I knew enough to know that I was a wicked sinner and that I deserved death and hell for my high treason against the King of Kings, but that Jesus had paid my penalty on the cross if I would just trust in him, repent, and believe the gospel. And that's what I did when I was very young. And I've never regretted that. I've never had a reason to really doubt it.
And then growing up into college, were you? I've heard James White call you a geek, so if I have permission to call you a geek,
You do.
um, were you a geek, and that's why you got into astrophysics, or did focusing on astrophysics turn you into a geek?
Well, maybe a little bit of both, but I've always been interested in stuff that's interesting, and in science in particular. And it's not just astrophysics. I find all the branches of science just fascinating, and I have since I was a very young boy. I've loved science. I like to understand how things work, and there's just something fascinating about outer space. I don't know what it is, but I was in. I mean, I was the Star Wars generation, right? Because Star Wars came out in '77, I think, and I remember seeing that and thinking that was amazing, and that probably stimulated my interest. But even aside from that, there's just something about the planets and the stars. When I'd go to our little local county library, and I'd get all the books on astronomy that I could find, and read through them, and these amazing, beautiful pictures. I mean, the beauty of the universe is just stunning, and that captured my imagination. And to understand how all these things work, I was destined to go into astrophysics. It's just something the Lord put on my heart that's interesting to me, and I find it fascinating, and I love sharing that information with others too, and see the light bulb go on, and they get excited about it too. But all fields of science, I find them all fascinating, but you can only get it. Well, some people get multiple PhDs, but I don't have that kind of time. So I had to kind of pick one, and astrophysics is my special love.
You came and spoke at our church some years ago, and I asked an earnest question, but everybody kind of laughed at me, and I guess it's probably good for me to get laughed at more. But I asked the question, like, what does an astrophysicist do? And you said that there's no industrial application, but I don't know if that was really what I meant. Have you gotten that question other times as well?
Yeah, I mean, the astrophysicist studies the universe, basically everything that happens beyond Earth. So it is an enormous field, and there are subdisciplines, but anything that happens beyond the Earth is something that would be studied by an astrophysicist, especially the mechanisms by which it happens. So the mechanisms of gravity, or the particle interactions that happen. Anything that happens in deep space is something that we study, and we do it because it's interesting. Because sometimes people will ask, depending on how the question is asked, what would I do with an astrophysics degree? And the answer is you teach astrophysics or you research, and neither of those has any kind of industrial application. As opposed to something like polymer chemistry, I like chemistry too, and I briefly considered going that direction. That's something that has tremendous application because you can make things that are useful in society. Whereas an astrophysicist, we study the universe because it's fascinating. It doesn't have a whole lot of practical application these days, anyway. I mean, there was a time when if you wanted to navigate, if you were on a ship, you better know something about astronomy and how to calculate things. But now with GPS and things like that, that's not as necessary. There's already been an astronomer who's done the work for you and put up these satellites so you can measure your position on Earth. But astronomy, it really is just a fascinating field, And what you do with it is you study it and try to learn more about the universe, and maybe you teach it. I do a little bit of both. I do mostly teaching, but I get to do a little bit of research sometimes.
I was reading on your Answers in Genesis bio some of the research that you did on the sun and the magnetic fields of the sun. Were there any, not industrial applications, but like in terms of being able to measure orbits for satellites and things like that? Was that helpful in adjusting timing calculations, or was that like figuring out how the magnetic field that the sun produces sort of keeps harmful rays out of the solar system and things like that?
That would be, yeah, the latter would be the only relevant sort of application to everyday life on Earth, is how does the sun affect weather on the Earth? And in fact, I believe some of the funding that went into the research that I was doing back at Gila when I was at the University of Colorado came from a program that was designed to um, study weather, how Earth weather is affected by solar phenomena, and it is affected by solar phenomena. Even this year, we've had some spectacular displays of aurora, northern lights. I got to see some here in Colorado. They usually don't make it down this far.
Yeah, I saw some
But
here in Idaho, which, I mean, they make it down there. They make it up to here more often than Colorado, but
sure.
my family in Texas saw it even.
Mm-hmm. And that tells you that the sun has been very active this year. So that'll affect northern lights. But in terms of weather, yeah, when the sun is more active, it puts out a little more energy. Earth's temperatures are a little warmer. So there is some question as to how the sun affects weather. The sun's magnetic field is part of the mechanism that blocks cosmic rays. The Earth has a magnetic field that blocks cosmic rays as well. These particles that stream through space that are dangerous to human DNA. So that would be one of very few practical applications of solar astrophysics. But the main reason I studied it is because it's interesting. I like to know how the sun works. And so there wasn't a whole lot of practical application that came out of my research. I discovered that there are these giant cells that were predicted to exist, and I detected observationally their boundaries, because the supergranules tend to collect. Supergranules are the large overturning cells in the sun, and they tend to collect in the downflow lanes of these giant cells. And I was able to spot those using the SOHO spacecraft and software that I had written that was designed to detect those kind of features. So does that have practical application? No, but it's interesting. It tells us something about how the sun works.
Are you able to do any kinds of predictions on sun cycles or anything like that?
The one thing that we can do, we know that the sun has a 22-year magnetic cycle, where the dipole field of the sun, which is kind of like the magnetic field of the Earth. It's got a north and south pole, but every 11 years it flips. And then 11 years later, it flips back. So 22 years for the complete cycle. And associated with that are periods of sunspot activity, where you have lots and lots of sunspots on the sun. And sunspots are associated with magnetism as well. So that we can predict. We know that every 11 years, you're going to get a surge of sunspots. And then in the down times, you have relatively few sunspots. So that's one of the cycles that's predictable. But there are larger scale cycles, well, we don't know that they're cycles, but there are larger scale trends that we don't know quite how they work. We know, for example, that in the mid 1600s, that even during solar maximum, there were relatively few sunspots. There was a period of many decades where the sun just didn't have many spots on it. So it had relatively low magnetic activity. And that was called the Mondor minimum. And we don't know what caused that. And it could happen again. And that was associated with cooler temperatures on the Earth, what we call the Little Ice Age, especially in Europe, where there were cooler temperatures, we think, associated with that solar activity. That we can't predict. So we can predict the 22-year cycle because it's very regular. But these larger scale patterns, we're not able to predict them yet. The more we study the sun, the more we'll be able to perhaps predict those in the future.
You just need a wider slice of time to be able to detect
that
the
would
pattern.
help. That would help.
If there's a 300-year cycle and you haven't been observing it in that level of detail for that long, how would you know?
Right. But we don't know that it's cyclic, right? Because I mean, there could be, like you said, there could be a 300-year cycle that we haven't discovered yet, or it could be irregular. It could be that, 300 years later, and then the next time it's 800 years later, and the next time it's 200 years later. It wouldn't have to be regular. And by studying the patterns on the sun, the motions on the sun with fields like helioseismology or correlation tracking, which I did, which measures surface motions, that tells us how these magnetic fields get pushed around. So it's an exciting area of research. It's something that I haven't pursued much since I graduated, actually. That was the work I did to get my PhD.
Well, and when you get into like cutting level research stuff too, it's you don't know what you don't know, and you don't know if there might be some kind of application or a new way of looking at things.
True.
You have all of these famous examples like Madame Curie or whatever. There was film developed in a drawer, and she was like, it was just next to these rocks. What does this have to do? And now all the research on radioactivity that's been done has tremendous application, but it was because nobody was asking the right question until somebody just happened upon something that didn't quite make sense, and you just have to look into it before you can even tell what does this mean.
True. And all that applies in astronomy too, but I would expect less practical application because like one of the areas that I find very interesting is extrasolar planets. The fact that we've now found planets orbiting other stars. I think that's amazing. And I would love to know more about these planets just because they're there. God made them, they're interesting, and I want to know more about them. But that probably will not lead to a lot of application on Earth because what these planets do and how many of them there are probably doesn't have a lot of Earth application. So I guess the main point I'm making is if you go into astronomy, you'll do it because it's interesting. You won't do it to make a lot of money. You won't do it because it's going to make some new gadget on Earth. I mean, that could result, but you'd be better off going into polymer chemistry or physics on Earth where you're in a laboratory, you're doing things that you could replicate for other people if it turns out to be useful.
But if you chase that, you're apt to be disappointed.
I think
just
so.
happy.
I think so. Yeah.
There'll be some bonus every once in a while maybe, but that's not the reason you get into it.
I think so. But again, I can't speak for everybody. I like to do stuff because it's interesting, but there are people. I mean, if you want to make a lot of money, okay, go into and you like science, go into like polymer chemistry. You will make a lot. You will be guaranteed to make a lot of money in that field. You'll $200,000 starting salary. That's not a problem. But yeah, it depends on what your interests are. And if you're like me and you just like science for its own sake, then you're probably not as concerned about making money. You're not as concerned about practical application. You just want to know what's out there. And astronomy is a great field for that.
Do you have a favorite slice of the electromagnetic spectrum? Tell me about.
I'm a visual astronomy guy, so I tend to focus on the same wavelengths that the human eye can see. Mainly out of practicality. That's what, I have a telescope, and when I look through it, those are the wavelengths I see. And so that's always kind of captured my interest. Interestingly, when I was working at the Creation Museum over with Answers in Genesis, they had, and I was, designing the new programs and so on, because I wrote several of the planetarium programs there. One of the modes you could do was you could show the sky in different wavelengths. And that was fun. It was fun to see because you could turn off the visible wavelengths so the stars go away and you turn on X-rays and the sky looks very different in X-rays. But, I've always wanted to know what does Superman see when he goes out at night? And so that's what the sky looks like in X-rays. Or you can turn on, the cosmic microwave background, see what the sky looks like in microwaves or infrared or whatever. And that's all interesting too. It's just I don't have a lot of expertise in that. So when I turned on the X-ray sky, I had no idea what that bright spot was or that one. But visible sky, I can tell you what's there. I can tell you what's what. So that's my only area of expertise. I do have night vision goggles now, and they can actually see a little bit into the infrared, what we call the near infrared. And so that's opened up some new possibilities. There are certain nebulae that are easily visible in night vision goggles that you really can't see naked eye very well. Some of them are in the deep red where theoretically you can see them, but at night you're using the rods of your eye and they are not sensitive to red. So certain nebulae like the Eagle Nebula, very hard to see in a telescope. And it just looks like a faint blob if you see anything. But you put the night vision goggles on it and an H alpha filter, and that thing glows and it's gorgeous. So that's opened up some new possibilities for me into the near infrared or places like H alpha, which are theoretically visible but are very hard to see at night when you're using your rods. But I'm primarily a visible astronomy guy.
So is H alpha, is that like the last kind of sliver before you get into infrared?
Pretty close to it. Yeah, it's in the deep red portion of the spectrum. And it happens that a lot of stellar phenomena glow at that specific wavelength because it's associated with an electron dropping from level 3 to level 2 in a hydrogen atom. It produces that specific color, that specific wavelength of light. And so a lot of nebulae glow very brightly in H alpha. And I got a filter that'll block everything except H alpha. The problem is with your eye, you see nothing because your rods are not sensitive to that frequency of light. But you put night vision goggles on it and it glows because they love red. Night vision goggles like red and even near infrared.
So what's happening with James Webb right now?
A lot of cool stuff. A lot of stuff that the secularists were not expecting. A lot of stuff that biblical creationists were expecting. You don't tend to hear about that too much because it goes against the narrative. But stuff that we predicted, stuff that I predicted back in January of 2022, I predicted the James Webb would see galaxies at much greater distances than secularists were expecting. That these galaxies would be full, mature galaxies comparable in mass to nearby galaxies, fully formed galaxies, spirals, things like that. And that's what it detected. It detected that these galaxies are at far greater distances than the secularists were expecting, and they were much bigger, much more massive than secularists were expecting. And the reason for the difference in predictions is I reject the Big Bang. I believe in biblical creation. That gives me an advantage.
So,
The secularists,
evolutionists think that there's actually like a nearer horizon where there's nothing outside of that, because from the Big Bang thing, even with how many billions of years it's been, hasn't had time to actually spread out that far.
That's right. So yeah, basically. So in the Big Bang model, the universe exploded into existence 13.8 billion years ago, rapidly expanded. It's got pure energy in it. The energy cools and forms atoms. And then hundreds of millions of years later, some of those atoms come together and form stars. And then the stars collect and form galaxies. So the idea is it takes hundreds of millions of years for the first galaxies to form. And so if you look out far enough, and the secularists would say that's like looking back in time because it took the light a long time to get from there to here. So if you look out far enough, you should look to a distance and therefore a time in their view where galaxies hadn't formed yet. And they were expecting that at a redshift of something like 14, because that corresponds to an age of just a few 100 million years after the Big Bang. You shouldn't have galaxies beyond that distance, but we do. I don't believe you're looking back in time. I believe the Bible uses an anisotropic or visual synchrony convention whereby we're seeing the universe in real time. That doesn't mean the alternative is wrong. It just means it's different. It's a different classification system than the Bible's using. But because of that, because God made the stars on day 4, their light reached Earth immediately. I would expect all galaxies would look kind of similar to nearby galaxies. I would not expect them to stop at a certain distance. I think God made them probably all the way out. There might be an infinite number of galaxies, but in any case, and I would expect that they would not form from babies because God spoke the stars into existence. They didn't need billions of years to form and then aggregate into galaxies. God created them, and it was supernatural. And so I would expect even the farthest galaxies would be fully formed galaxies. In the same way that God made Adam and Eve as adults, I believe He made the galaxies as adults. And that's exactly what we see. The James Webb Space Telescope is confirming those most distant galaxies. They're massive. They're comparable in mass to nearby galaxies. They're not babies. They're not clumpy. They're spiral galaxies. They're fully formed, and they're at much greater distances than the secularists expect. Distances beyond a redshift of 14, out to like a redshift of 20 in some cases, and perhaps they'll go even further out.
How are they able to calculate distances? Is it, you're triangulating from one edge of orbit to another, and they're having to try to see which ones move in relation to each other? How are they doing that?
That would be the best way to do it. But that method, these galaxies are so far away, that method doesn't really work very well. That would be a parallax method. That works for stars within our own galaxy, but that method won't even work out to the next galaxy because the change in distance, the change in perspective is so small. That's a good method. It's nice, it's easy, it's geometrical. No, the way they're calculating distances is purely by redshift at this point. Edwin Hubble, back in the 1920s, calculated the distance to nearby galaxies using some good methods, not from parallax, but he used basically what are called standard candle methods. That has to do with where you find an object whose intrinsic brightness is known for whatever reason, and you notice how bright it appears, and then knowing that light diminishes as the distance squared, you can compute the distance. And there are several types of standard candles you can use. He used Cepheid variable stars. These are pulsating stars, and the period of their pulsation is related to their intrinsic brightness by a particular mathematical relation that was known. And he used that relation then to calculate the true brightness of these Cepheids that he saw in the Andromeda galaxy, and then measured how bright they appeared and was able to calculate their distance. And that's how he determined the distance to the Andromeda galaxy and many other galaxies. And he found that generally, he also measured the redshift of these galaxies, the fact that their light has been stretched from their stationary frequency or wavelength. And he found that the farther away a galaxy is, the more its light is redshifted. And so what modern astronomers do is they use that Hubble law, the fact that the redshift correlates with the distance, that when you find a distant galaxy, you measure its redshift, and you get the distance that way. It's an approximation, but it's the best we can do for galaxies that are that far out.
Do you have to assume a certain level of brightness for a galaxy to be able to calculate what it started at to then figure out how much it's diminished?
No, because the way they're doing it is they're using the redshift of the galaxy, the redshift of the light. And we know we can measure exactly how much the light's been redshifted because there are certain frequencies of light that are prominent in that galaxy, like H alpha, which I mentioned earlier. Certain
You can
nebulae
tell how
emit.
much it's gone down from, it's emitting some of that.
Yeah, it's not, and in this case, it's not brightness that we're using. In this case, it's the stretching of the light from one frequency
Higher
to
frequency
another.
to a lower frequency.
Yeah. Now the brightness does drop too, but that's not what we're using to do the calculation. We're using the stretching, how much the light's been stretched, and we can nail that down very, very precisely.
And that's because you can assume a rough, what the stars are composed of.
Right.
So that's the assumption that you're then using as a starting point.
I would say that even that's not really an assumption because composition, these spectral, it turns out different substances will give off different frequencies of light. And certain frequencies will be missing. Like in a star, there are certain frequencies of light that are missing or at least reduced. They're diminished. And so it's like an atomic fingerprint that tells you what the star is made of. And hydrogen has a very characteristic fingerprint. In fact, it's one of the few that I can recognize just like that. If it's hydrogen
kind of
lines,
like
I can tell you.
I've seen it stretched out. It's like a color barcode, essentially.
Yes.
And then, then you can see that proportionally everything is shifted down, but the spacing all lines up perfectly. So that's what it originally was.
Yep. So the redshift. So basically, by splitting the light into a spectrum, we know both what the galaxy is made of and how fast it's moving away from us. And assuming that the Hubble law is right, then the redshift is proportional to distance. That's the assumption, is that the Hubble law continues to apply at increasing distances. And that's probably a good approximation, but it's not exact. The redshift we can measure exactly. The distance is an approximation.
Do you have any requests that are in the queue for things for James Webb to look at? Have you been involved with anything?
No official requests. I'm not even sure how to go about that process or if they would even allow it. I wasn't part of the team that designed it. I didn't spend any money on it, so I don't know if they would listen to me. I have suggested I would love to see them take multiple deep field images of the same spot in the universe and look for supernovae, because I've made some predictions about the brightness of supernovae that would confirm my model and would refute the Big Bang if they're accurate. So I'd love to see that happen, but will they do that? I don't know. They will if other astronomers have a similar interest, basically. So we'll see if that happens. I'm just happy to look at the data that they're recording wherever they point it. They share the data. They share the data, and I'm happy to look at it and discover, make some new discoveries about what's in there, and that's been really exciting.
It just goes to show you reap what you sow, even in the questions that you ask. Your worldview limits the questions that you think would even make sense, and so you even limit the things that you're able to learn, because it wouldn't make sense for that to be. So why even ask that question? Even at the highest level, we can put a telescope in outer space, and we're still limited by our own thinking. Just the way God designed human psychology is fascinating to me too.
It's true. Yep, it's true.
So there's a distant starlight problem for the evolutionists that we just covered. What was the distant starlight problem that it seems has been solved by the anisotropic synchrony convention that you have coined, I suppose?
Yeah.
What was your thought process in solving that? How did you come about that? Because that was all using stuff that Einstein had come up with, wasn't it?
Yep. So the starlight problem basically is this accusation that biblical creation can't be true because the biblical timescale is a few thousand years, something like 6,000 years ago that God created the heaven, the earth, and whatever's in them. Can't get an exact date, but it wouldn't be millions or billions of years. And yet we see stars that are so far away that theoretically their light should have taken billions of years to get from there to here. And we see the stars, so the light has gone from there to here. And since that takes billions of years, that proves, allegedly, that those stars are at least billions of years old. And that means the universe is at least billions of years old because it contains those stars. Well, part of the problem with that is it assumes a synchrony convention. It assumes a method by which we define what now means in distant space. And that may sound trivial. What does now mean? Well, now is the time that you make the statement. I look at my watch and it has a time, and I say now, I'm referring to that time. And that makes sense here. But what about something way over there, something that's far away? If I look at the time on that, is that the time? Is that now? Or has it taken the light time to get from there to here? And most people assume it takes the light time to get from there to here. We know that if you take light, send it to a mirror, bounce it back, it will take time to make that journey. And most people assume that it took the same time to go out as it did to come back. And one of the things that Einstein discovered is not only do we not know that, you can't know that, because the speed of light in one direction is not something that is determined by nature. It's not something that God set. It's something that we get to choose. And that tells us how to define what now means at a distance. I know that's mind blowing, but it's something that Einstein wrote about in his primer on relativity. And it occurred to me, we could define the speed of light when it's incoming to be instantaneous, no matter where it comes from. And then it takes light no time at all to get from those galaxies to the Earth.
And it doesn't break anything.
Say again?
It doesn't break anything to do that.
No, it's perfectly consistent with known physics, that the fact that you can make the one-way speed of light up to infinity in one direction. Now, you can't make it infinity both ways. So you can't get light there and then bounce it back immediately. It'll one leg of the trip will take time, but it doesn't have to be both legs. It could be just one leg, and then the other leg is instantaneous. And as I did a little more research into it, I found that all ancient cultures used that convention whereby light, when it's incoming, is instantaneous. They would define now as when you see something happening. And so if you see a star explode, or if I saw a star explode right now, and somebody asked me, when did that happen? I'd say, well, duh, it's happening right now. I'm seeing it, right? It was only after Einstein that people, well, not entirely after Einstein, but it was only really in the 1600s, a little bit before Einstein, that people started to say, well, even though we're seeing it now, it really happened a long time ago, and the light took a long time to get here. Einstein says you can't say that dogmatically. You can stipulate that, but you can't assume that that's fundamentally true. You could define it to where the light arrives immediately. And I think the Bible does that, because when we read in Genesis that God made the lights to be for signs, seasons, days, and years, and to give light on the earth, it says, and it was so. And it was so indicates that the light they immediately gave light on the earth. They immediately fulfilled their God-ordained rule to give light on the earth. It didn't take any time.
That day,
and all ancient cultures used that. Right. All ancient cultures used the convention whereby we're seeing the night sky in real time. And that happened up until about the 1600s. Galileo suspected that maybe we're not seeing it in real time. And Romer thought he had proved that we weren't seeing it in real time. And then Einstein says, actually, you can't know one way or the other because it's a matter of convention. And that's the part that I've had difficulty communicating to laymen. But I did write a book about it called The Physics of Einstein that gives people an introduction to the physics of Einstein and why, when you understand physics properly, you cannot say that the universe must be billions of years old just because we can see billions of light years away. That just means the universe is big. We can see the universe in real time if you use this visual synchrony convention, which all ancient cultures did, and the Bible apparently does.
So how come nobody else thought to use things that Einstein had known? Is it 100 years or coming up on 100 years since he put that to paper?
Yeah, it's been more than 100 years. Yeah, I think it was 1905 that he published his special relativity, and that's all you need to know. But the idea, Einstein tended to prefer the convention whereby the speed of light's the same that way as this way for any observer, which you would think would create contradictions. But basically Einstein said that's because this person has a different definition of synchronized clocks than that person. So they're allowed to contradict because they're not using the same synchrony standard, basically. And that's become so ingrained and so conventional because it makes the math easier. There's a reason why most astronomers do it that way. But most astronomers don't realize you don't have to do it that way. That's the key. And I didn't realize that. I'd taken classes in physics and relativity in particular, even as an undergraduate. I took one as a graduate as well. And we didn't really cover synchrony conventions. We just used the Einstein synchrony convention, the one he preferred.
Because it's where you get to think of light as a particle and nothing but a particle. Because every particle takes time to travel and it's the same in all directions. That makes sense, I think, to most people.
Yeah, perhaps so. But because we've been trained to think that the speed of light has to be the same, the one-way speed has to be the same in all directions for each observer, which creates a contradiction if you think about it. If you take that as an absolute, because then it would mean that if the light's going this speed and then Michael's going half that speed, the light should be different in different directions for him, but it's not. It creates contradictions, and Einstein accepted that, but said that the answer is to recognize that they're using different conventions of now. And that's the principle called the relativity of simultaneity. If anybody wants to look into that, there's a chapter in Einstein's book on that phenomenon. But most people don't realize that what that means is, because simultaneity is relative, I can make the one-way speed of light instantaneous in one direction. And this was something that it's an obscure aspect. That's the thing. It's not terribly useful in those situations. And so most people haven't thought about it. But a guy named John Winnie in the 1970s published 2 articles where he showed that all of relativity works no matter what the one-way speed of light is. You can define it to be anything between half c and infinity, and all the physics of relativity works perfectly fine. And that's never been refuted, although some people have tried. And so that's called the conventionality of simultaneity. And some physicists are aware of it. There are some secularists who would say, yeah, Lisle's right. The one-way speed of light can be anything between half c and infinity. And therefore, you can be seeing the universe in real time. Sarkar and Stachel wrote a wonderful paper about that back in '99. And they're not creationists. One of them, I think it's Sarkar, is an adamant evolutionist. So you can't accuse him of trying to solve the starlight problem for creationists. He hates creationists. But he just pointed out the advantages of using an anisotropic synchrony convention. So it's something that if you go through the literature, it's there. It's just most physicists are not aware of it because it doesn't come up very often. So I think that's why it was overlooked. But it's something that I stumbled upon in grad school. I kind of thought that I had discovered it, and then I looked through the physics literature, and actually, no, I didn't discover it. For the last 100 years, people have pointed out that the one-way speed of light doesn't have to be the same as the round trip speed.
Was there an epiphany that you had that made you realize that its application for the young Earth creation distant starlight problem?
Yes, and that occurred when I was in grad school, and that's been a long time now, so I kind of forget the details of it. But I remember talking with one of my colleagues, and he professed to be an atheist, but we would have good conversations sometimes, and he couldn't see any problem with it. And I thought, he's a sharp guy, so we talked about that a little bit, and the fact that you can't objectively measure the one-way speed of light without first assuming it. That was mind-blowing to me. And then I realized, yes, that would solve the distant starlight problem. In 2001, I wrote a preliminary article advocating that idea. And then, but I wasn't real happy with that. And then in 2010, I updated that article and made a more, I think, a better case for it. My understanding of physics had improved in the intervening 9 years. So, and that is published in the Answers Research Journal. I believe it's in 2010 was the issue where I showed how the anisotropic synchrony convention can solve the distant starlight problem, or rather reveal that there is no distant starlight problem. That's probably a better way to put it.
Yeah, it's fascinating to me. That's probably the least controversial thing that you've popularized. There's a YouTube channel, Veritasium, that posted a really excellent video on it as well.
I saw that.
It's nothing debatable, really. And he's definitely an old Earth evolutionary thinker.
Yeah. It's funny, though, because there are these wonderful papers that have been written throughout the 20th century showing how you can't measure the one-way speed of light without first assuming it. And people are like, oh, that can't be true. And then there's YouTube video comes out and they're like, oh, it must be true. There's a YouTube video.
No, the Veritasium's production quality is very high.
It is.
So it makes it a little bit more...
And I've seen that video. It's well done. It really is well done.
Yeah, I think I might have been one of the first people to send it to you. Let's see here. So the flat Earth movement, why is that movement not dying, or why did it come around again?
I think the way it came around again was the leader of the movement, Eric Dubay. He's not a Christian, and I think he and others have tried to. I know in the past there were some people who tried to push the idea that the Bible teaches a flat Earth, which it doesn't, but they were trying to mock Christianity. And some well-intentioned but maybe not so well-educated Christians said, "Oh, well, maybe the Earth really is flat then," because they're taking a secularist who doesn't know how to read the Bible. He's pulling verses out of context and trying to convince people the Bible teaches a flat Earth. And then well-intentioned Christians who want to believe the Bible, want to defend it, they, I think, bought into that. But the reason it continues to survive, and the only reason, is the internet. That's the only reason it continues to. If somebody believes in a flat Earth, it's because they saw a video on the internet that convinced them, because some guy spun a tennis ball and they said, yeah, that can't be the Earth. And somebody who doesn't know anything about physics, and uh, I guarantee you, anyone who believes in the flat Earth, it's because they've seen YouTube videos and they are conspiracy theorists. And there is a psychology there that I don't fully understand, but it's rooted in pride. It's rooted in the idea that I've seen something. All of you have been fooled by the government and NASA into believing that the world's round, but I've seen through it because I've seen these YouTube videos, and I'm, it's a pride issue. It's very easy to demonstrate that the Earth is round, and I've done it. I've done experiments that have tested that based on the positions of stars using trigonometry. It's not hard to do, and I've got some articles on our website showing experiments you can do to test the shape of the Earth, and it's not hard. It's not hard. You just need to do a little bit of math. And it's high school math. It's not even like calculus or anything. It's trigonometry, for heaven's sake. And you can prove that the world is round that way. But you will never meet a flat earther who can pass a trigonometry class. Won't happen.
Is there, just to play devil's advocate, there's something a little bit healthy in questioning things that everybody thinks are true, and to like re-examine and to double check and verify things. You don't want to take absolutely everybody else's opinion to form all of your own. It's healthy for somebody to go and verify something for themselves and convince themselves directly.
Right. Which is why I put up these experiments. But yeah, I respect the person who says, hey, I went through a public education system. I was taught evolution, and now I know that's not true. Amen. And they say, but I was also taught the world's round. So maybe, is that a lie too? Well, no, not everything you taught in public education is wrong. A good fraction of it, perhaps, but not everything. And you can test the shape of the Earth for yourself. Here's some experiments you can do. Here's some pictures from my friend Jeff Williams, who's an astronaut. He points the camera out the window. There, the Bible says the testimony of two eyewitnesses is true. So you've got more than two people who have been astronauts who've been to space and taken pictures and so on. So there's lots of ways to establish that. But I do respect a person who questions the narrative. We should do that from time to time. But I have little respect for a person who questions everything. A person who says, well, everything's a conspiracy. The government's lying to us about everything. No, not everything. There are real conspiracies, don't get me wrong. And sometimes people lie, and sometimes they collaborate to lie to trick you. Don't get me wrong. But not everything's a conspiracy. And we shouldn't have a conspiratorial attitude about us, I think, where we're just people who doubt that we landed on the moon. And it's just, do you understand how many thousands and thousands of people were involved in the Apollo program, and how many people would have to be in on that? It's not feasible. I mean, Watergate proved that just a very small handful of people couldn't keep a lie straight. And that's why the Bible says the testimony of 2 or 3 witnesses is true.
It's the same type of thing, people saying that there was a verse here or there that was sneaked in. And well, it's like the, as difficult as slipping in something to the blockchain in Bitcoin or something. Do you know how many copies you would have had to go back and alter? And all of the copies have been made of those copies and those copies and those copies. The work that you'd have to do to go slip something in back down the line just is astronomical.
And we can very easily refute those kind of claims because we now have very ancient copies of the Bible. So we know where it's, I mean, when people copied the Bible, human beings are not perfect copy machines, and they do occasionally make mistakes. But we now know where those have happened because we have these ancient copies, and we can see that, oh yeah, in the year 1200, this mistake was made. And nobody's trying to go in there and add in verses and things like that. They're innocent mistakes, but I know a little something about textual criticism, and I have a good friend who knows a lot about textual criticism and, about how the Bible's been transmitted and copied. And so this idea that people have tried to add or subtract verses is ridiculous. It is true that sometimes statements will get added from the margins because sometimes people, when they were copying the Bible, they would put notes in the margins. But sometimes when they're copying scripture and they realize they left out a verse, oops, they'll write the verse in the margin. And so the next person who gets that copy, he sees a note in the margin. He doesn't know if that's the text of scripture or a comment that somebody was making on the text of scripture. And so what do? Do you include it? Do you not include it? Well, you better include it for the sake of completion. And so we know that there have been some places where something's been slipped in like that. It's a marginal gloss. It happens. But we now know virtually every place where that's happened because we have these very ancient copies. And so if people want to know more about that, there's software you can get where you can find out what the original text read. In just about every case, we know what the original is. There's only a very few places where there's some dispute. Is it this or this? And it has to be one of the two. So if people are interested in that, they can research textual criticism. But the idea that there are all these spurious verses in the Bible, that is not defensible. The vast majority of the verses in the Bible we're confident they were in the original, and the very few that are disputed, the modern Bibles like the NASB, they'll give you both options. They'll say most ancient manuscripts don't have this verse, but they'll include it anyway, so you can make up your own mind.
So looking back on your progress you went through Ohio Wesleyan and University of Colorado.
Yep.
I've heard somebody make the assertion that new, like, major discoveries come from the fringe of a particular field of study. Have you found that to be the case? How would you respond to that?
Well, there might be something to that, because if something's very mainstream, it's, if somebody discovers something that everybody predicted, is it really a discovery? It's not the one that gets talked about the most. I think the most exciting discoveries are things that people were not expecting, and therefore they're not a prediction of the standard model, if that makes sense. And so things like quantum physics, relativity, these came out. Neither of those fields was really anticipated. Newton would not have expected something like the physics of Einstein to have been discovered, or the what we would call quantum physics. Newton didn't know about those, and there were phenomena that he could have explained if he'd known about them. The dual particle wave nature of light. Newton had some idea about that, but he didn't really know what the answer was. And it was Einstein discovered the photoelectric effect, and that began our modern understanding of quantum physics. So the cool stuff in science is the stuff that's not expected, that goes against the mainstream, I think. So people who are very adamant we need to stick to the consensus, the mainstream, they will not make scientific discoveries, right? Because if something is what you predicted, it's not really a discovery. It's when you discover something that's unexpected that really makes it a discovery and adds to our understanding of science.
Well, and thinking about it like a tree as well, there are discoveries that the branches can make and be bent to grow in new directions, whereas the base of the tree is inflexible. And that's by design. And so you need that to a certain extent, which I guess is probably why the university setting is so interesting, because you've got people who are established in a field, but then they also need the students who can ask, brain-bending questions or mind-numbing questions, as the case may be, to sort of keep the trunk of the tree on its toes, so to speak.
Yeah. I mean, there are things in science that are very well established. There are other things that we think are well established, but maybe they're not, and we need people questioning those. So questioning in science is good. It's a good thing to do. And it's good to be able to answer those questions and say, well, here's the reason we came to this conclusion. And so, a lot of people say, well, if we teach creation, do we have to teach every other idea? Well, when I teach astronomy, I do teach in addition to our understanding of the solar system today, I teach the old understanding as well. And here's why we don't believe that anymore. I teach here's the geocentric model. They used to think the planets and the sun orbited the Earth, and the Earth was stationary and in the middle. There's a reason we don't teach that anymore. I mean, there's a reason we don't believe that anymore, but I still introduce that to my students, why it's wrong, how we discovered otherwise. So I do think it's good to cover, here's the directions we went in the past that were kind of wrong directions. Here's why we don't believe in them anymore. Give students a good logical basis for their beliefs, which is really what it's all about. That's what education should be about, is about having logical reasons for the things that you believe and abandoning those things that don't have logical reasons. And science ought to follow that same standard. And when it doesn't, you get things like evolution and deep time and so on.
I've heard from other fields that the world of peer-reviewed scientific journals has become sort of a bragging right via sheer numbers, instead of like actually trying to push the boundaries of a field. Have you found that to be the case personally, or with people that you know?
Yeah, that can be. I mean, I do respect people that have a lot of published articles, but it's more about for me, it's more about the quality of the article than the quantity. I've published relatively few peer-reviewed journal papers. I got a few out there, but I'd like to think that the ones I've published are very good quality and move science forward. I think they all do. So that's more what I'm looking at. But yeah, there are people that just like to publish, and there's nothing wrong with that. There's nothing wrong with publishing. I mean, there are people that have published well over 1,000 peer-reviewed journal articles. But the main question I'm going to ask is, are they any good? Do they advance the cause of science? Maybe pick out what's your favorite one. What do you think most has pushed science forward? And send me that one. I'd like to read it. That's kind of the way I'd like to look at it.
Do you think it might be there's just a different push when you're on a university tenure? Like they like to see that somebody's pushing out a lot of material?
Yeah, that's definitely true, and that's something we need to be a little bit concerned about. Yeah, you're more secure in your position at a university if you put out a lot of papers, especially if you don't have tenure yet, and the university is looking to give you tenure. They'll look to see how many peer-reviewed papers have you published, and if you've published a lot, they'll be more likely to give you. So there is a push to publish more papers rather than maybe fewer papers that are of higher quality. That's true. That's an unfortunate aspect of the way the situation is at the moment.
Is there anybody that you would recommend replicate your PhD study?
Well, I mean, we certainly need more PhD scientists out there. I think that's a very good thing. But a lot of people, I try to bring my enthusiasm. I love what I do, and I try to bring that enthusiasm forth. And sometimes people get the impression that doing science is just fun all the time. Well, it has its aspects, but a lot of it can be very tedious. It really depends on what you want to do. So what I would say is, look at the Bible. What does the Bible say we're supposed to do in life? After you've taken that into consideration, what do you feel that God has placed in your heart to desire that is in line with his will, that's in line with the scriptures? Because if our heart's not in line with the scriptures, and it tends not to be, then that's no good. People say, follow your heart. Well, your heart's desperately wicked, the Bible says. But if your heart's regenerated, if you're serving Christ, you want to say, what gets me excited about serving Christ? And if it's in the lines of science, then that might be something you want to go into. But then there's the question of what do you want to do with it? And I got to tell you, the PhD program, it's not for everybody. It's different from an undergraduate education. I thoroughly enjoyed my undergraduate education. My graduate education, I didn't enjoy as much. I felt like it was a little more, learn this, learn that. Whereas my undergraduate, and it could just be the difference in the schools. I don't know. I mean, I had good professors at all of them, but undergraduate, it's more about enjoying the topic and things like that. And graduate school was a little more, we're preparing you now to go out and get a job and to do this, which was a little less fun for me. But there are aspects of research that can be very tedious. You might spend a month working on something that doesn't go anywhere. It's a dead end, and you realize that was a waste of my month. You still learn something. You learn what not to do, but I got to tell you, when you make that moment of discovery, when I saw those supergranules line up and along the edge of a giant cell, I knew I was onto something, and that's very cool. Because when you make a scientific discovery for a few minutes, there's something that only you and God know, and that's very cool. And then, of course, you want to share it with everybody, and then everybody else knows. But still, you were the one to find it, and it's like God's giving you this little secret. He's whispering in your ear, and science is a neat way to do that. So if that's something that appeals to you, it's something you could take it one step at a time. Go to a college, major in a field of science. If you love that and you're like, man, I want to do more of that, then you might want to consider grad school and a PhD program.
Are there any challenges to young Earth creationism that you think still carry weight? It was the distant starlight problem. Is there sort of the next thing?
Well, because I'm a presuppositionalist, I know that science itself would not be possible apart from the biblical worldview. So there can't be a scientific objection to the foundation of science, right? But there are things that we don't know the answer to, and I would like to know the answer to some of them. There's the issue of the heat that's produced during the global flood, and how do we dissipate that? Nobody's proved that it can't be done, but we don't exactly know the fullness of the mechanism by which the heat is dissipated to space and so on, because we don't want the oceans to boil and things like that. Not everywhere.
Was that just because of like underwater volcanoes and things?
Yeah.
Okay.
Yeah, and plate tectonics, and perhaps we think that the radioactive decay rates were accelerated, and that produces quite a lot of heat. And you want some heat because you need heat to get the plate tectonics going. So that's not a negative thing. Heat is a good thing. You need it to power the worldwide flood. But then there's a question of, is it too much? How do we get rid of the heat? You want to eventually dissipate it to space. There are multiple mechanisms to do that. Hurricanes do that. We think during the flood, there would have been hypercanes, which are hurricanes on a much more massive scale that would efficiently dump heat to space. Is it enough? And creation physicists and geophysicists are doing these kind of calculations, and there's not a consensus answer yet. I'd kind of like to know the answer to that. It's not so much a problem. It's just some people would say it is. Some people say, well, that there's the heat problem. Well, it's just we don't know what the answer is to it, but nobody's proved that it can't be done. Or what is the cause of the cosmic microwave background radiation? I would love to know the answer to that. I've got some ideas, but I don't know for sure what caused it. The secularists say, well, it's the afterglow of a Big Bang. You don't know the cause either. That's just a story you tell. Right? I mean, I could make up a story too, and it wouldn't be necessarily any more true than your story. So sometimes people get won over because the secularists have a story, and even though it's not right, they at least have a story that makes sense of the evidence. I would say I'm willing to wait and not have a story until I'm fairly confident that I've got the right story. And I think that's a better approach in science, but it requires patience. And it requires you to not know the answer to some things, like the cause of the cosmic microwave background, things like that.
I know some people as well who I think they place a greater importance on not looking backwards. And so they'll just sort of accept the first challenge that somebody gives to them and punt something, rather than say, I don't know the answer. I'm not necessarily going to throw away everything that I believe. But still, like, let me take your question seriously, because you don't want to be flippant with somebody asking you a serious, difficult question, but you also don't want to say, it's more important for me to look smart than to trust God.
It's perfectly okay to say, I don't know the answer to that. But again, if you're a presuppositionalist like I am, you can say, I don't know the answer to that, but I do know this. If the Bible were not true, you couldn't even ask the question. The question wouldn't make any sense, because you're presupposing that God upholds things in a uniform way. That's Genesis 8:22. I mean, these are all things that come out of a Christian biblical worldview. Science comes out of a Christian worldview. That's why I'm not afraid to ask the questions, because I know the answer would have to be consistent with Christianity, because science comes out of a Christian worldview. It wouldn't make sense. It wouldn't work. It wouldn't be justified. We would not have any reason to trust the scientific method if the Bible weren't true. And so I'm perfectly happy to answer questions and ask questions about specific aspects of creation. And I'm perfectly happy to say, I don't know the details of the answer to that. I know it's got to be possible because science is possible, and that is enabled by biblical creation, but I don't know the details.
Going back to the your university education for a second, you mentioned something about it made me want to ask: was there a focus on like the business side of getting your PhD? After you've graduated as an astrophysicist, how do you get a job? How do you start your career? Was there talk about that? How did they help you through that kind of thing?
Yeah, they did. They did. And again, with astrophysics, because there is virtually no industrial application, with almost any other field of science, you could go into continued research, you could go into teaching, or you could go into industry. And with astronomy, that third peg is gone. So you're either going to continue to do research or you're going to teach. And a lot of professors end up doing a little bit of both. And that's kind of a fun situation. And when I started grad school, that's kind of what I thought I would do. I thought I'd be a full-time professor, do some teaching, do some research. That's a nice combination. And I kind of do get to do that. I just do it in regards to the Christian ministry. But yeah, there was discussion about that, and we're always looking at even when you get towards the end of your PhD, my advisor very kindly said, there's an opening here at Stanford or Lockheed Martin, I forget where all they were looking at, but and he would have been happy to to write me letters of recommendation and so on. So there is some thought given to that. That's certainly true. It's just by the time I was near the end, I thought, I think I'm going to go into apologetics ministry, which is probably not where they were expecting me to go into.
So the biggest significance I see Scripture mention, and you mentioned it earlier in the podcast, you've got the heavens for signs, season, days, and years. Are there other significances that you have found as the reason, other than, or is the main reason just God's glory and just showing how powerful He is?
Yeah, I think those are the main ones: signs, seasons, days, and years, and revealing God's glory. And the Bible. The nice thing about those is the Bible specifically teaches all those. The signs, seasons, days, and years, basically to keep time. That's mentioned in Genesis chapter 1. That's the purpose of the stars. And then Psalm 19:1 indicates that they declare God's glory. That's the one that I tend to focus on, because when I look at the universe, I'm in awe of its creator, because the universe is amazing, it's stunning, and to think that God spoke that into existence is um, it just makes you want to bow down and worship God. It really does.
I
It's
think
a
one
neat
of the
experience.
Psalms will even just sort of use it flippantly, like God rolls it up like a garment.
Hmm. Yeah, rolls it up like a scroll, rolls it up like a mantle. Yeah, and because He created it and He can uncreate it just as easily. Some question, does that refer to the last day? Then when He rolls it up and so on. But in any case, it's God's to create, it's God's to uphold, it's God's to destroy, it's God's to remake as a new heavens and a new earth, of course. So, but yeah, it's God's creation. It is magnificent. It stimulates my mind. When you think of the sizes of these stars or the distances between them, which is just unimaginable, it blows your mind. You look at these little pinpoints of light in the night sky, and you think those are like the sun. Those, the sun's 100 Earths across, and those are as bright as the sun. Most of them are brighter if you can see them, but they're tiny. They look tiny because they're so far away. It just gives you an appreciation for the mind of God, who upholds all that, who controls every atom in every one of those stars, who has a name for each one of those stars and a purpose for it. It's just astonishing. So it really gives you an appreciation of the magnificence of our Creator.
Do you see any kind of significance of fractal patterns where there's a similarity between like the atomic structure and a solar system, that kind of thing? Have you ever done much thinking on that?
Yeah, well, yeah, it's kind of two different issues there. So the solar system and atoms, in some sense, resemble each other. There's some differences too, because at the
You
quantum
speak of
level,
orbits, but even though it's not necessarily, a particle going around in a
yeah,
circle necessarily.
there is a similarity. There is a similarity, um, and that's because the same God upholds both. So there are patterns in nature, and we'd expect that because God's mind is mathematical, and so the same kind of math that upholds atoms, that keeps atoms together, keeps solar systems together. Even the way the forces diminish, gravity diminishes as r squared. The electromagnetic forces that keep the electrons orbiting the proton diminishes as r squared. So the same kind of patterns exist. So that's wonderful. With regard to fractals, fractals are structures that repeat on smaller and smaller scales. And we do see that in space. The structures, the large scale structure of the universe appears to be fractal, where you have these strings, filaments of galaxies surrounding voids where there are relatively few galaxies. So the galaxies are not just randomly distributed. I mean, they are in one sense, but there are some kind of pattern there. And it's like kind of like a cobweb, where you have, bubbles where there's relatively few webs, or if any, and then you have other places where the webs are very thick. The structure of galaxies resembles that. And so that is fractal in nature. And I'm a fan of fractals. I've studied them. I've written a book about them because they reflect God's thinking. And there are fractals that occur when you plot certain sets in mathematics. You plot them on the Argand plane, you get fractals, and they're stunningly beautiful. And we see some of those in nature as well, because the mind that's responsible for mathematics is the same mind that's upholding this universe, namely the mind of God. And that's why we can do that. A Nobel Prize-winning physicist, Eugene Wigner, wrote an article called "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." And
That's
it's
a
a wonderful
title.
article.
That's a
Yeah, it's a
title.
wonderful article. And he shows from his apparently non-Christian view that there is no reason to expect the universe to obey math. And so he's amazed that it does. He's grateful that it does, although he doesn't say who he's grateful to. Interestingly, gratitude, gratitude's built into us because we're designed to worship the living God. But the funny thing is, any child who is a solid Christian can explain why the universe obeys math. It's because the same God who made math made the universe. And I think that's neat that God takes the wisdom from the wise and prudent, gives it unto babes, and it's delightful in His eyes.
So, how might our view of the heavens influence our conduct in this life?
Well, yeah, if you see the heavens as a random accident, that we're just part of a big bang just exploded us into existence. We're just star stuff, as Carl Sagan used to say. We're stardust. We're just chemical accidents. That's going to affect, if you're a logical person, that'll affect the way you live, because you'll think, well, human beings don't have any intrinsic value. We're just accidents of nature, and therefore I can do what I want if I want to get ahead logically. And whereas if the universe is spoken into existence by an all-powerful God, and I am also that God's creation, I better listen to what that God has to say, because the God who spoke those billions of stars into existence and upholds them by the word of his power and can destroy them just as easily as created them, that's not a God that I want to be on his bad side. That's a God that I want to be right with him. I want to be reconciled to him. And that means I'm going to obey his commandments. Of course, we fall short. We need a savior, but I'm motivated out of gratitude and love for my savior to obey his commandments. I see other human beings not as cosmic accidents, but as beings that are made in God's image bearers, and therefore deserving of dignity and respect. And that's going to affect the way that I behave to and around other humans. So I think it has a huge effect. Where the universe came from, where you came from, is going to affect, if you're logical, the way you behave.
Well, we're short on time, so I won't get into the talking about ultimate proof of creation, but I would recommend people go. There's an excellent DVD set where you can get, how many hours is it? It's like 4 hours long, something like that.
Yeah, you're talking about the one from AIG. I've updated it a little bit. So we have a new one on our, if you can get it on our website, the Ultimate Proof of Creation. That's just 1 hour, but I think I've improved it a little bit, so it's a little bit better. And then the book, of course, the Ultimate Proof of Creation, which you can get on our website at biblicalscienceinstitute.com, along with a lot of other great resources. And that's going to show you how to demonstrate that biblical creation has to be true, because it's a necessary prerequisite for anything else to be true.
Do you have an economic outlook on space exploration and colonizing Mars? Elon Musk is probably a name that comes to mind.
If anybody can do it, it would be Elon. I mean, he's done some amazing stuff, and I wish him all the best. I like the fact that he's taking it private. Don't get me wrong. I'm a fan of NASA. I think they've done amazing things. It's just my outlook on the government is God hasn't really authorized the government to spend taxpayer money that way. I mean, we can enjoy the results, but I like that
NASA is sort of a kinder Nebuchadnezzar.
Yeah, that's a good way of looking at it. Yeah, and and there are lots of good Christians in NASA. Don't get me wrong, and I'm friends with some of them, and I even got a tour of the NASA headquarters led by an astronaut. It's an amazing organization. God bless them. It's just I would rather their funding be private rather than from the government, because God has authorized the government to punish evildoers and reward the good, not really to fund space program. That's a different topic, but I like that Elon's taking it private, and I think that's a good way to go, and he's got the money to do it. Mars was not designed for life, however. It's not Earth. It's you've seen these probes, and it looks kind of earthy, but you don't see plants and animals there because it's not designed for life. It's got a real thin carbon dioxide atmosphere, a very weak remnant magnetic field, which does not deflect cosmic rays very efficiently. So if anybody goes to Mars, they will be able to live there for maybe 2 years, and then they'll have to come back to the confines of Earth to be protected from cosmic radiation. The astronauts in the space station are protected from that mostly because the magnetic field extends quite a ways beyond the Earth, but it doesn't go out to Mars. So I mean, as fun as that would be, and I'd like to see it happen, don't get me wrong. Whether it'll happen, I don't know. It's a big ask. It's a big ask.
The moon is still the furthest that anybody's ever been away from Earth, right?
Yes. Yep. And that's 240,000 miles away. Mars, depending on where it is in relation to Earth, it's millions of miles away. It's much further away than the moon. And so the moon takes a few days to get there. Mars will take, well, it depends on the kind of rocket that they use, but a minimum of like 6 months. So it's a totally different ballgame.
Do you think too that there's a little bit of that's sort of like the modern day version of the Tower of Babel? Because God says we're created from dust and will return to dust, and our reaction is, I'm going to get as far away from Earth as possible. But there's still a certain level of it that's inescapable. You know, you're going to be dust, even if you die on Mars.
Yeah. That attitude can certainly happen. It depends on the individual, though, because some people argued that when we went to the moon, that we were making a new Tower of Babel. But Neil Armstrong, Buzz Aldrin is he's a Christian, and when he was on the moon, he took communion, and he was trying to do it to honor God, and I really appreciate that. So It'll vary from individual to individual. I hope the people that end up going, if anybody ends up going, are people that have a biblical worldview, and out of a desire to explore God's amazing creation. That's the reason they're going, and not as a way of rebelling against God, because God's not against building tall towers, right? There's nothing intrinsically wrong. I mean, we've built skyscrapers that are bigger than the Tower of Babel, but God's concern is the motivation. What's your motivation for doing that? And the Tower of Babel, it was to build a tower whose top is unto heaven, apparently dedicated to the worship of the heavenlies, worshiping God's creation rather than the Creator himself. And God does not appreciate that. He's a jealous God. He rightly deserves our worship and not his creation. So it'll depend on the people that are in the program, and it'll probably be a mix. There'll probably be some people that have good motives and others that have not so good motives.
There's an interesting book called The Skyscraper Curse, which talks about the economics of building super tall buildings. And, after every time the world record for tallest building is broken, within a year, that city undergoes the worst economic depression it's ever seen. So I think it's a little bit of a God saying, like, hey, don't forget, like, this isn't something that you should be super focused on.
Okay. Yeah. Interesting.
Tell the audience where they can find more resources from you.
Check us out. Biblical Science Institute is the name of the ministry, and our website's just that. It's biblicalscienceinstitute.com. Biblicalscienceinstitute.com. A lot of great free resources on the website, a lot of great articles. There's a search engine. Any topic you can think of, we've probably written on it. And if not, we'll get to it soon. So, and then there's a web store as well. If you want to get some of the books and DVDs, I'd highly recommend those as well. And if you want to support us, there's a donate button. You can donate monthly or just a one-time gift. We appreciate all that. It keeps us going. So, but the main website itself, we wanted to make that freely accessible to everyone. So biblicalscienceinstitute.com.
Appreciate the work that you do, Jason.
Thank you.